The method of superposition takes the summation of individual hydrographs derived from the unit hydrograph. Check this next example here in hydrology. From the previous videos, when we derive a unit hydrograph, note that the examples such as the one presented contain a direct run of hydrograph with 2 hours intervals. Then we have converted this DRH into a unit hydrograph of the same interval, a 2-hour unit hydrograph. So to cut it short, a 2-hour DRH is provided and converted into a 2-hour unit hydrograph, or a 3-hour DRH was converted into a 3-hour UH. But how if what we have is a 3-hour DRH and what we needed is a 2-hour unit hydrograph? Are we just going to work on ratio and proportion? The height or discharge can be transformed by merely division or multiplication, but with change of duration, specific methods are employed, one of which is the S-curve method. Besides the time and discharge usually provided, the method requires computing the coordinates of an S-curve. This is another additional column to be completed to arrive at the transformed unit hydrograph. This approach is a bit more technical, but this does not have any limitations. Thus, it is considered as the general procedure. Another approach is simpler than the general procedure. It is the method of superposition. The procedure of this method is simple, however, it has a limitation. The method of superposition only applies when the required unit hydrograph is a multiple of the provided UH. For example, superposition can be used if the problem provides a 3-hour UH and the required is a 12-hour unit hydrograph. 12 is a multiple of 3. A 2-hour unit hydrograph corresponding to a 1 centimeter effective rainfall is established for a certain watershed. Recently, a storm produces a rainfall hyetograph, and we are to compute the direct run of hydrograph by the method of superposition, after which we are to determine the peak discharge and the time of peak. The second table shows the variability of the storm according to different time intervals. The direct runoff can be computed individually according to the excess rainfall on each interval. At the start of the storm until 2 hours, the rainfall excess is 0.5. This is then multiplied to the unit hydrograph to identify the direct runoff on the first 2 hours. So at T2, DRH is 25 times 0.5 or 12.5, followed by 60 times 0.5 or 30. Then 40 times 0.5 is 20, with 15 times 0.5, which is 7.5. Then T10 has 0. At time interval 2 to 4 hours, the depth is 1 centimeter. This is multiplied to the UH, thus having 25, 60, 40, 15, and 0 for the DRH. Next is at time interval 4 to 6 hours. The depth of rainfall is 0.8. This is multiplied to the unit hydrograph, thus having 20 at T2, 48 at T4, 32 at T6, 12 at T8, and 0 at T10. During the 6 to 8 hours, the rainfall decreased to 0.4 centimeters. Multiply this to the UH to have 10 at T2, 24 at T4, 16 at T6, 6 at T8, then 0 again at T10. For the last interval of the storm, the rainfall turned 0.3. Again, multiply these to the unit hydrograph and have 7.5 at T2, 18 at T4, 12 at T6, 4.5 at T8, then 0 at T10. With the individual direct runoff hydrographs already determined, we employ the method of superposition. The first DRH is at 2 hours, so entries start at T2. Then for the interval 2 to 4 hours, the direct runoff then lags to the end, which is 4 hours. For the next DRH, the coordinates then lag a little lower to T6, followed by the DRH between 6 to 8, where the runoff starts at T8. Then, for the last interval, the DRH lags to T10. Summarizing all direct runoffs into a single table, we are now ready to compute the total runoff. T2 has 12.5. T4 has 30 plus 25, giving 55. T6 has 20 plus 60 plus 20, which is 100. Followed by T8 with 7.5 plus 40 plus 48 plus 10, giving 105.5. T10 consists of 0 plus 15 plus 32 plus 24 plus 7.5, and that is 78.5. At T12, the entries are 0 plus 12 plus 16 plus 18, which is 46. This is followed by 6 plus 12 or 18, then 0 with 4.5, which is 4.5. The last is 0. Now that the total runoff is complete, we can easily identify the peak discharge, and that is 105.5 cumex at T8. Here is a practice problem for you to master the method. A watershed has established a 3-hour unit hydrograph using 1 centimeter effective excess rainfall. A storm provided a hyetograph of 3-hour intervals. The task is to determine the direct runoff hydrograph from which you identify the peak discharge. By following the procedure, you should be able to compute the peak discharge as 160.5 cumex, and this occurs at T12 hours. Good luck!